In this video, we are going to look at this MIT integration B question which appeared in the 2025 final question. This was a tiebreaker problem. So the answer to this integral is shown below in yellow pen, that is here. So you may want to try this integral before following the steps in the video. So we are going to start off by just looking at the integrand. So in the integrand without the square root, which is x raised to the power 4 minus 4x plus 3. This one has a repeated factor of 1. It has a repeated factor, a repeated root. Let me say repeated root of 1, because 1 is a root of this polynomial. When you plug in 1, that is going to give you 0. Why is a repeated root of 1? Because when we take the differential of this is 4x to the third power minus 4. And then 1 is also a root of this polynomial, and that is after the differential. So that implies that 1 is a repeated root of this polynomial. So since 1 is a repeated root of this polynomial, it implies that x minus 1 multiplied by x minus 1 is a factor of this polynomial. And that gives you x squared minus 2x plus 1. So this is a factor of this polynomial. So in order to get the other polynomial, we have to do a polynomial long division, right? So I'm going to divide this polynomial, x raised to the power 4. There is no x raised to the power 3 term, so I'm going to just write as 0x to the third plus 0x squared. Then I have minus 4x plus 3. That's the same polynomial. I'm going to divide by its factor, which is x squared minus 2x plus 1. And now let's do the polynomial long division. This one divided by the x squared, that is going to give you x squared. And then you multiply, you're going to have x raised to the power 4 minus 2x to the third power plus x squared. And then you subtract. When you subtract, this x raised to the power 4 terms will go, and then you have 0x to the third minus 2x raised to the power 3. That is going to give you 2x raised to the power 3, and then minus 0x squared minus x squared. That is going to give you x squared minus x squared. Then you bring these guys down here, 4x and 3. You divide again, that is 2x to the third divided by x squared. That is going to give you x 2x. Then you multiply, that is going to give you 2x to the third minus 4x squared plus 2x. Then you subtract. When you subtract, this is going to give you minus x squared minus 4x squared. That is going to give you positive 3x to the second power. And then minus 4x minus 2x, that is going to give you minus 6x, and then plus 3. Then you divide, that is 3x squared divided by x squared, that is going to give you 3. And when you multiply, that is going to give you 3x squared minus 6x plus 3. You see that this term and this term are now the same. So when you subtract, that is going to give you 0. Cool and sweet. So that implies that when you divide this polynomial, x raised to the power 4 minus 4x plus 3 divided by its factor, x squared minus 2x plus 1, this gives you the quotient. This is the quotient or the answer as a result of the polynomial long division. That is x squared plus 2x plus 3. Now this is what we have. So this one, that means that x raised to the power 4 minus 4x plus 3 is the same as x squared plus 2x plus 3. This one multiplied by x squared minus 2x plus 1. So this is what we have. So x raised to the power 4 minus 4x plus 3 is equals to, this one is the same as x minus 1 all squared. There's a repeated root of 1, which is multiplied by x squared plus 2x plus 3. So this is how we can factorize our polynomial. And then we now have the integral. So I is the integral of this guy, the square root of this guy. So it is the square root of x raised to the power 4 minus 4x plus 3 dx. So we are just going to take the integral of the square root of x minus 1 squared multiplied by x squared plus 2x plus 3 dx. So instead of integrating this, which is impossible, we now have to tackle this one. Cool. So I is going to be equal to the integral. So this one can now be split into two different roots. We have the square root of x minus 1 squared, and then the square root of x squared plus 2x plus 3 dx. So this one cancels this, and then we have I to be equal to the integral of x minus 1 multiplied by the square root of x squared plus 2x plus 3 dx. Now let's split this one into two different integrals. That is the integral of x multiplied by the square root of x squared plus 2x plus 3 dx minus the integral of the square root of x squared plus 2x plus 3 dx. That is just distributing in with this one. Cool result. Now let's look at this one again. So when we look at this one, the differential of this one is 2x plus 2, right? So we have to get something like 2x plus 2 outside the square root. So in order to get 2x plus 2, what we have to do is to first of all multiply this integral by 2. So let's do that. Multiplying it by 2, we have 2x. But we can't just multiply by 2. We have to nullify the 2 by dividing the integral by 2. Then we have the square root of x squared plus 2x plus 3. And then dx minus the integral of the square root of x squared plus 2x plus 3 dx. Now we are left with plus 2 because the differential of this one is 2x plus 2. Now we have to add 2 to the integral, the first one. So this is 1/2 the integral of 2x plus 2. But I can't just add 2, I have to subtract 2 to nullify the effect. So this is what I have. So I can group this one into 1 and then the minus 2 into another one. Then I'm going to multiply by the square root of x squared plus 2x plus 3 dx minus the integral of the square root of x squared plus 2x plus 3 dx. This is what we have. This is the same as our original integral, that is this one. Okay, so now let's split this one into two different integrals. So I is going to be 1/2 the integral of this one multiplied by this, which is 2x plus 2 multiplied by the square root of x squared plus 2x plus 3 dx. And then this one multiplied by the 2 with half in front of the integral. So the integral of 2 multiplied by the square root of x squared plus 2x plus 3 dx. And then minus this integral, which is the integral of the square root of x squared plus 2x plus 3 dx. Cool result. Now this one will cancel the 2 and then we have just 1. So this is 1/2 the integral of the square root of x squared plus 2x plus 3, which is multiplied by 2x plus 2 dx. The first one, this has cancelled, and this is now minus the integral of the square root of x squared plus 2x plus 3 dx minus the integral of the square root of x squared plus 2x plus 3 dx. This can combine into 2, so that's now negative 2, right? So this is 1/2 the integral of the square root of x squared plus 2x plus 3 multiplied by 2x plus 2, which we wanted, dx, and then minus 2 the integral of the square root of x squared plus 2x plus 2. Enough of the white pen. We are now going to divide, tackle this integral one after the other. I'm going to call this one integral 1 and the second one integral 2. So let's tackle the first one in yellow as we always do. So the first one, I1, is 1/2 the integral of the square root of x squared plus 2x plus 3 times 2x plus 2 dx. I'm going to do a u sub here. I'm going to let u to be equal to what is inside the square root, which is x squared plus 2x plus 2 plus 3. Beg your pardon. Then we take the differential. Du is going to be equal to 2x plus 2 dx. So in place of 2x plus 2 dx, that I'm going to replace that with du. So our integral in the u world is I1 to be equal to 1/2 the integral of the square root of u, and then this one is du. That's very easy now. So this is 1/2 the integral of u raised to the power half du. Cool stuff. So I1 is 1/2. Integrating this is u raised to the power 1/2 plus 1 all over the new power 1/2 plus 1, which is equals to 1/2 u raised to the power 3 over 2 all over 3 over 2. This is 1/2 multiplied by the reciprocal of 3 over 2, which is 2 over 3 u raised to the power 3 over 2. And that is 1/3 u raised to the power 3 over 2. But what is u? U is x squared plus 2x plus 3. So that implies that I1 is equals to 1/3 x squared plus 2x plus 3 raised to the power 3 over 2. This is the answer to the first integral, I1. Now let's tackle I2 in a different color to make things colorful. So the second one is 2 times I2 is 2 times the integral of the square root of x squared plus 2x plus 3 dx. That is the second one here, this one. Now let's deal with this one. This one we can complete the squares, but it's very easy to complete the squares here. This is 2, the integral of the square root. What is inside the square root can be written as x plus 1 squared plus 2 dx. Because this one, that one is x squared plus 2x plus 1. When you FOIL that, you get x squared plus 2x plus 1. Then you add 2, you have your x squared plus 2x plus 3. So that is what we have here. And now we are going to do a trick sub here. I am going to let x plus 1 to be equal to the square root of 2 times the tangent of theta. This is the substitution that we are going to use to solve this integral. And now what we have now is going to be equal to, we can now differentiate. So dx is going to be root of 2 secant square of theta d theta. That means in place of dx, I'm going to replace with root of 2 secant square of theta d theta. And now we can take the integral from the x world into the theta world. So we have 2, the integral of the square root of this is now square root of 2 tangent of theta. So the square root of 2 tangent of theta squared plus 2, and dx is the square root of 2 secant square of theta d theta. So we have I2 to be equal to 2 times the integral. This is the square root of, the square of this is 2 tan square of theta plus 2. Then root of 2 secant square of theta d theta. So I2 is going to be equal to root of 2 is a constant, can come out in front here, 2 root of 2, then the integral. This can be written as the square root of 2 times the square root of 1 plus the tangent of theta. That is this one. And then times secant square of theta d theta. So I2 is going to be equal to this root of 2 is also a constant, it comes out in front here. We have 2 root of 2 times root of 2, which is 4. And then the integral of the square root of secant squared of theta times secant squared of theta d theta. We are using this identity, the identity that 1 plus the tan square of theta. I beg your pardon, there is square here. 1 plus the tan square of theta is equals to the secant square of theta. So I'm just replacing 1 plus tan square of theta squared with secant square of theta. And this is for the integral of this is secant of theta times secant square of theta d theta, because the square will cancel the square root, and that is left with 4 times the integral of the secant to the third power of theta d theta. So this is what we have. So now integrating secant to the third power of theta, this is we have done this before severally. I'm just going to write down the integral, the resulting value of this integral. So this one is secant of theta times tangent of theta. That is 1/2 plus 1/2 the natural logarithm of the secant of theta plus the tangent of theta, like this. So this one is the resulting value of the integral. So if we integrate secant to the third power of theta, this is what we are going to get. And now 1/2 is a common, you can factorize that one out, it come out and multiply the 4, that gives you 2, and then we have secant of theta tangent of theta plus the ln of the absolute value of secant of theta plus the tangent of theta. Now we have to move back into the x world. We have to go back to our substitution. The substitution will let x plus 1 to be equal to root of 2 tangent of theta. I'm going to switch pens here and deal with that. So our substitution, we let x plus 2 to be equal to square root of 2 is x plus 1. I beg your pardon. It's x plus 1. Sorry about that. So this one is x plus 1. So x plus 1 to be equal to the square root of 2 tangent of theta. That implies that the tangent of theta is equals to x plus 1 all over the square root of 2. So we can draw a right triangle here with our right angle here, with our angle here, theta. Tangent of theta is opposite over adjacent. The opposite is x plus 1 and the adjacent is the square root of 2. So we can find the hypotenuse, which is the line opposite to the right angle h. So the hypotenuse squared is equal to the sum of squares of the other sides, which is the opposite squared, x plus 1 squared, plus the square of the adjacent, which is the square root of 2. So h squared, the hypotenuse, is foiling this is x squared plus 2x plus 1 plus the square of root 2 is 2. So h squared is x squared plus 2x plus 3. That is 1 plus 2. And then h is the square root of x squared plus 2x plus 3. So that is the hypotenuse. And now that we have the hypotenuse, we can find secant of theta in terms of x. So we already know tangent of theta is x plus 1 all over square root of 2. Secant of theta is the opposite of the cosine of theta. If cosine of theta is adjacent over hypotenuse, then the secant of theta is hypotenuse over adjacent. The hypotenuse we just got to be the square root of x squared plus 2x plus 3. All over the adjacent is the square root of 2. So we have secant of theta, which is this, and the tangent of theta, which is that. So we can just take our integral from the theta world into the x world. So now let's do that. So this is I2 is 2 times secant of theta tangent of theta. Secant of theta is the square root of x squared plus 2x plus 3 all over the square root of 2 times tangent of theta is x plus 1 all over the square root of 2 tangent of theta, x plus 1 all over square root of 2, and then plus the natural logarithm of secant of theta plus tangent of theta. So secant of theta is the square root of x squared plus 2x plus 3 all over the square root of 2 plus tangent of theta is x plus 1 all over the square root of 2, like this. So this is I2 in terms of x. So I2 is going to be equal to 2 times, we can now multiply these guys out. So that is x plus 1 multiplied by the square root of x squared plus 2x plus 3 all over root of 2 times root of 2 is 2, and then plus the ln of these guys, which is the square root of x squared plus 2x plus 3 plus x plus 1 all over the square root of 2. I have a common denominator now. So we can now multiply in with 2. When you multiply in with 2, we have this one, we cancel that. And then we have x plus 1 multiplied by the square root of x squared plus 2x plus 3. And then plus this 2 multiplied by this, we have 2, the ln of the absolute value of the square root of x squared plus 2x plus 3 plus x plus 1 all over the square root of 2, like this, in absolute value. So this is the resulting value of the second integral, right? And now you can now wrap up the integral. Our integral I is integral I1 minus integral I2. So that is if you go to the very top. So this is I1, and then we have, it was I1 minus I2. That is what we have. So I1 is 1/3 x squared plus 2x plus 3 raised to the power 3 over 2. So I is 1/3 x squared plus 2x plus 3 raised to the power 3 over 2 minus I2, and then I2 is this one, which is x plus 1 square root of x squared plus 2x plus 3, and then minus, because that is going to make this one negative, minus 2 ln of the absolute value of the square root of x squared plus 2x plus 3 plus x plus 1 all over the square root of 2 plus the constant of integration. Cool result. So now this one is 1/3 times x squared plus 2x plus 3 raised to the power 3 over 2 minus x plus 1, the square root of x squared plus 2x plus 3, then minus 2 using the laws of indices, that is going to laws of logarithm, that is going to be the ln of the absolute value of the square root of x squared plus 2x plus 3 plus x plus 1 minus the ln of the square root of 2, like this, plus the constant of integration. So I is going to be 1/3 x squared plus 2x plus 3 raised to the power 3 over 2 minus x plus 1, the square root of x squared plus 2x plus 3 minus 2 times the ln of the absolute value of the square root of x squared plus 2x plus 3 plus x plus 1, and then minus 2 times negative this, that is going to be positive 2 ln of the square root of 2 plus constant. You can classify this one as another constant of integration. So finally we have I to be equal to 1/3 x to the second plus 2x plus 3 raised to the power 3 over 2 minus x plus 1, the square root of x squared plus 2x plus 3 minus 2 ln of the absolute value of the square root of x squared plus 2x plus 3 plus x plus 1 plus a bigger constant or another constant of integration. So this one is the answer to our integral. So this one conforms with the answer that I gave in the beginning of the video. If we go to the very top, so this one is equal to our answer here, that is this one here. So that is the answer to this beautiful integral. If you know an easier way to solve this, I know this is a very long video. If you know an easier way to solve this, please leave a comment in the comment section. Let me know how we can solve this one faster. So I thank you so much for watching this video. If you find that helpful, please give me a thumbs up and subscribe to Calculus Diaries for more engaging content on integrals. I thank you so much for watching this video, and I will catch you up in the next one. Bye bye.